right.
All right. So do you want to hold this or do you want to speak there?
I can hold this.
Okay.
All right. Well, first of all, thanks for the introduction. Thanks for inviting me. Really excited about what I'm about to talk about today. I've been working on signing artifacts for the better part of 5 years. Before I founded Testifysec, I did a lot of work with the DoD, worked for JSOC, and then I did a lot of consulting. I led the defense practice for a small consultancy called Boxboat before they were sold to IBM. And what our customers are really concerned about was, how do I know that the thing that my developers produced, right, is the thing I'm actually running in production? And how do I validate the metadata around this? And when we started working on this problem, there wasn't really anything out there that solved this problem, right? We were forced to trust developers that they followed the correct process, right, implicitly. There was no explicit way to validate those processes, right? So, and this is fine when we're talking about a single organization that has a structure that we can provide accountability over. But when we're talking about open source communities, that's not always the case, right? We have a process and we need a way to be able to trust in that process. So when we're doing that, right, we need to go beyond just something like a GPC signature or even something like some of the stuff that SigStore does with its binary assigning. So when we're talking about a GPC signature, right, this is called an empty attestation, right? We're just signing the SHA-256 sum or the SHA sum of that artifact, right? We don't have any metadata associated with that signature other than the identity, right? So it's assigning an identity to an artifact, but not to a process, right? We know nothing about what happened. There's no build verification, right? We don't know what source that came from, right? We don't know the process that was used to build that. If you look at like the XZ attack, right, there was no process metadata about that, right? We had to have some great engineer figure out that happened, right? If we record what happens in these processes, we can validate that later on to know that, hey, the process that the developers for this project, the OpenCHAMI project, have developed, that was a process that was actually followed. So what is an attestation? Well, an attestation is just me stating something. My name is Cole Kennedy. That is an attestation, right? But when we're talking in context of software supply chain security, we can be a little bit more specific. So there's an envelope format called a dead simple signing envelope. This is the same envelope if you use SigStore to sign an artifact, cosign, any of this stuff, right? They're going to use that same standard. That is a standard that has been developed by the in-toto project, the in-toto community. Within that envelope, we can store metadata. There's a block to store signatures, and then there's a block to store the actual metadata about the thing that you care about, right? So within that block, there's different fields, right? And for an in-toto attestation, it's required to have both materials and products. These are the inputs and the outputs. If you think about how you build software, it's a graph, right? You have inputs coming from different areas and you have outputs going to the other areas. And these get really complex, right? When you have a bunch of dependencies and such like that. But if you track the inputs and the outputs, you can guarantee the correctness of the system, or at least what things went where, right? And then there's other attestations that we can have too, the auxiliary and metadata about where that thing happened. Think about if we run ls, right? Well, there's metadata associated. What is a command that we ran? What was the system that we ran it? Does that system have a TPM? Maybe that TPM has an identity, right? So we can start collecting metadata about what happened. And these are different types of attestations. So with these attestations, now we can evaluate them with a policy to come out with a decision. So with in-toto, specifically witness policy, that allows us to scope different metadata in those attestations. So one of the things that makes in-toto policies very special is that they're scoped to multiple steps. As we spoke about in the last slide, right? A software supply chain is made up of inputs and outputs that are laid out on a graph, right? Or a chain, right? This allows us, in-toto allows us to validate that whole entire chain, that integrity from source to build to distribution, right? The policy allows us to define that chain, what attestations are required at every single step of that chain, what functionaries, right? What signatures are we expecting on that attestation? And then how that chain is laid out, what that graph is laid out at. So the final effect of this is that we can specify specifically what RPMs are allowed into our system based upon the process that they went through. If we never got an SBOM generated for that RPM, guess what? We can say no access, right? If we do have an SBOM, but it's using an old version of OpenSSL that's deprecated because it's got a security vulnerability in it, right? We can deny access to that at admission. So a policy can assert who, what, when, where in the chain of custody for any software artifact, whether it be an RPM, a container, right? We're just talking about a blob of bits here. So when we're talking about who ran it, right? What system did this come from? Was this built on a developer's machine sitting underneath his desk? Or was this built on our secured AWS GovCloud infrastructure with our hardened runners, right? That's an important distinction, right? What ran, right? Is this a build process? Is this a test process, right? Is this a static analysis, right? So this allows us to identify the commands that are run as part of the process. And then where, right? Kind of attached to who, but right, is this ran on a cloud runner, or are we using a local runner for this? And then of course when this event actually happened. And so we countersign all of the signatures with a timestamp authority. This is really important because when you issue a certificate, when you sign something, that certificate can be used for an entire certificate validity period. So if we're issuing certificates that last 2 years, if we lose that private key, someone can go use it for 2 years, right? So what we do is we use a short-lived certificate and then timestamp that, so we know that attestation was generated during the certificate validity period. This allows us to do that full verification across an air gap much easier. And then finally, chain of custody, right? We establish the graph, the data flow between the steps, and enforce that. All right. So we're going to get a little concrete. We're going to get concrete here about what a policy looks like. Now, these are simplified. If you go to our documentation, you'll find the full schema. But for brevity, this will be a little bit easier. So when we have a policy, we can see it expires at a certain time, right? And we have timestamp authorities, right? Who do we trust to timestamp that attestation? So we can put multiple certificates in there. And then public keys. We also can do certificate authorities as well. So if you're using a CA within your organization to sign things, we support that as well. And then this is where it comes in, that steps, right? What steps are required to be validated for this artifact? So you can see for this artifact, we have the first step is build, right? We want that build step to be attested. We want that build step to be attested that it happened from the source code that we trust and it happened on build infrastructure that we wanted. All right, so we're going to have different types of attestations that validate that. Second, we're going to take that compiled binary in a spec file, and we're going to turn that into an RPM, right? That's another transformation process that we're going to observe. The materials for the RPM process came from either the source code repository or, right, it was a new material from the product that came from the build step, right? So we record the SHA-SUM of the artifact that comes out of the build step, and we require that to be one of the ones in the RPM step, right? We're proving that integrity there. You can see that artifacts from. And then finally, we're gonna take that RPM and we're gonna use a tool called SIFT to generate an SBOM. And that way we have an inventory of the packages that were used to compile that and to build that. All right. So you can see here that we have a REGO policy. It says ban vulnerable OpenSSL. So I don't know if it's the best UX, but when you define a REGO policy within a witness policy, it has to be base 64 encoded. I can't decode that in my head, so I've decoded it over here. And you can see it's some complex Rego that's been code generated by Claude earlier today, and it does work. But this allows you to do version checks on the OpenSSL based upon the SBOM. But this is now cool. This is pretty cool because now we have an SBOM, build metadata, and source metadata that's all linked together. So we can query all this stuff on a graph. So if there's an issue in production, we know exactly what SBOM was attached to it, and we can query that with additional queries to figure out, hey, am I vulnerable? And this, if you think about what just happened with NPM, a lot of people are asking this right now. Am I vulnerable? And if you have this metadata, you can figure that out instantly and then remediate against that threat immediately. So this is really important because open source, we're going to have more backdoors. We're going to have more attacks, right? The ability to respond and act when that happens is extremely important. All right, so where does this fit? So I really don't understand your project that much. I've been learning a lot today about what you're doing. It sounds really, really exciting, way cooler than the stuff I do. But it seems that you're using GPCs to sign stuff right now. And there's definitely some limitations around GPG. But I think for sake of backwards compatibility, you leave that in there for who knows how long. I don't think it's that much to maintain. But then if you add a witness run around the critical build steps in the architecture or in the infrastructure, and then add a gate with witness verify with a policy, you can bring this capability to all your users at a fairly low cost as far as time and effort, especially if you use some of the open tooling that we've built to automate this within GitHub. All right, so let's go through a concrete demo here. And I'm going to be doing this through a terminal instead of going GitHub Actions to make it go a little bit quicker. But you should be able to translate this and how this would work in a CI system. So the first thing we're going to do is we're going to build a binary. We're going to use Go. It doesn't really matter what programming language it is, though. And then the next thing we're going to do is we're going to go ahead and build that RPM using the artifact from that build step. Then we're going to generate that SBOM, right? So with that, we have enough metadata to start gating our deployment. So we're going to gate that decision based upon some criteria. And then if we meet that criteria, we're going to go ahead and install that package. All right. So can everyone see that all right? I know it's might be a little small. A full screen there. There you go. All right. So Witness is a CLI tool. It's a library. There's a lot of different ways you can use it. So here we're using the CLI tool. In most CI situations, you would use one of our plugins, and I'll give you, I got a slide on that here in a little bit. So you can see we invoke Witness. We use the run command. We have to specify the step, and then we specify a signer. Now, we support a lot of different signers. If you are using like AWS KMS, you can use that. If you want to use SigStore because it's an open source project, we support that natively. And in fact, if you're using our GitHub action, you don't even really have to worry about signing stuff. It just like pulls those keys based upon the credentials that workflow is granted. But for here, we're just going to use a key that we generated. And then we're going to create an attestation, and we're going to call this build.json. Witness does have a companion project called Archivista that you can upload these attestations to. It's designed to help work across the air gap and talk more about that if you have questions, but we're not going to get into that too much. But we do have a back end for this as well that we're not demonstrating now. And then you can see our command is go build, and the output is software, and we're building main.go. So, right, we have this wrapper that's going to observe the process and collect metadata about it. All right, let's kick that off. All right, so that's the first step. Now we're doing the same thing, but now we're building the RPM. So you can see that, we have our spec file there. Let's go ahead and build that. All right, we've got our RPM built. And now we're going to go and use Ceph to generate an SBOM based upon that RPM. All right, let's look at one of those attestations. This is kind of mocked up to kind of show you what it is. There's a lot more detail in there. But you can see we have materials for the files that went in, and then we have the products, right? The software that came out. So that data is recorded. We can create policy against it. We can use that. And if it's uploaded to Archivista, we have a full GraphQL API to query these things. Right. So finally, we have that witness verify step right there. And that just takes all these files, the policy, the signed policy we created, all the attestations, and it sees if we have enough attestations to satisfy that policy. All right. And then it did. So we see it went end-to-end sudo RPM installed software.rpm. Bam. Right. So that software was fully validated and allowed us to pass that gate and install it. All right. Right. And you can see this is an example of what that policy would look like. It's fairly complex. We have tooling to generate these based upon the attestation, makes it a lot easier. Do not recommend sitting there and hand jamming these things. It's going to take you a very, very long time. Reach out to me. I do have some scripts that help with this. And then if we start looking at the attestations, right, you can see, we got that command. How do we build that software, right? The environment that software is built in, as well as a bunch of information about the git commit. So one of the nice things about these attesters is they're fully pluggable. Let's say you have like some company level metadata that you want to collect about your build system that's specific to your organization. Well, you can go ahead and create a witness plugin and it'll go collect that information and it'll put it as part of this attestation collection, and you can write policy against it. It's a fairly straightforward way to extend. It's fairly straightforward to extend witness in this way, but it does require engineering to do so. All right, so what happens when we don't have witness, right? So we're just going to go ahead and go build some software, right? It's wild, wild west out here. We don't need a CI system. We need to get this bug fixed and we need to ship it, right? Doesn't matter. Maybe our system's compromised. It doesn't matter. This needs to get out. So we're gonna go build it, and then we're just gonna sign it using our GPG key because we got it on our own system. We don't need this in our CI system. So now I hand this artifact over to my infrastructure team, and they're gonna go ahead and use witness verify against that policy that we have. And there we go, right? This developer is not allowed to do it this way, right? We have a process that needs to be followed in order to ship secure software. It wasn't followed, so we're not going to accept this into our environment. All right, let's go to another use case too. We have a version of our software that was built, let's say, 6 months ago. And as part of that, we generated an SBOM. And this is currently running on our production system. So let's go ahead and 6 months ago, right, we did this. We created the attestations for all the different steps. Here's the attestation for the SBOM. All right, we got that Cyclone DX. So now 6 months has passed and we have a new vulnerability. So we update our policy to restrict the versions of OpenSSL that are allowed in our production systems. So as a normal course of action, we're going to go ahead and validate all these RPMs. Maybe we do this on a cron job, every day or something. I don't know. Man, right now we can see we found an artifact that had the version of OpenSSL that we do not want in our system. Right. So we were able to look up that artifact, hash it, follow the graph that we built in Archivista or in the attestations to find the metadata that we need to say, hey, actually, right, this is wrong. This does not meet our policy, right? So it's that discoverability that attestations provide that give them a lot of power. All right. Any questions there before we go into air gap? Show of hands. How many of you operate in an air gapped? How many of you of your productions in air gap? The air gap is a very challenging situation, right? I think we get pushed to move software faster and faster every day, but yet it's like I gotta take this CD and physically move it into a different enclave, get it scanned, and do all these different things. I remember bringing those CDs over and manually writing down SHA sums and comparing them over the phone with people to validate these things. Because you have to, right? You don't have a choice. If you're working at like an IL6 secret or higher level environment, you have to do these integrity checks. It's so important, right? So there's a few different ways to do it. And the story is really not great outside of witness, right? So we have GPG signing. That's kind of been the status quo. We all know the issues with that. Right, so a few years ago, 6-store project was started, and cosign was one of the things there. And you can sign binaries with cosign. You can validate them over an air gap, but it wasn't built for that, right? The first cosign was first built for full online verification, and that's what it was designed for. So if you look at the user experience around doing offline verification of artifacts, it really stinks. It's not the best. It's hard to explain to auditors. So we designed Witness in order to make it easier, at least to explain to auditors, and then just to understand how we're doing the crypto. So for keyless identity, right? If you're using SigStore, your own instance of Falsio, this is exactly the same. We use the same identity. It's the same workload identity. Cosign, SigStore, they support using a timestamp authority. Actually came a little bit after Witness supported it. But this allows you to do the offline verification. Otherwise, you would need to do some crazy proof with Recore, and good luck explaining that to an auditor and how that's done. So then when we do offline air gap validation, cosign is going to use bundles, stamp proofs, and then has a tag for that. So you're going to have to write a lot of scripting around that. With Witness and Archivista, right? All the evidence is signed JSON documents. We use S3 as a storage mechanism for Archivista by default. So really what you need to do is just move all these JSONs into the storage bucket in your air gap, or an S3 compatible store in your air gap, or even just a file system, make them available, and then we can run Witness Verify, pointing them at that. So there's really not a lot of backend infrastructure or craziness that you need to do the verification. And then we go provenance depth. If you're using something like cosign, right? Those are the empty attestations. All it is an identity attached to the artifact. We're not doing any process validation whatsoever. We don't have any additional metadata about what happened. And then the certificate pinning and identity pinning is pretty similar between what cosign does and then what Witness will do. All right, so let's go with a demo here. So I have two terminals here. I have my my low side that's connected to the internet. And then over here, I have my air gap. So I'm going to go ahead and I'm going to start. So we're going to take those files that we built earlier in the demo, and we're going to go ahead and tar them up. All right, so we can see a bunch of them there. All right, so we have this bundle, it's just a tar file, we created it. All right, so now I'm going to hand this to somebody, and they're going to go walk it across the air gap, and they're going to go load it onto the other computer. All right, and so we're going to go onto our air gapped system. We're going to SSH into it. All right, and we check the SSH. Yep, it's the same file that we transferred over. Looks good, but let's do the full verification, right? We untar it, make all those files available, and then we run that same witness verify command that we ran on the low side, on the high side. And that allows us to do that verification without any connection to the internet. All right, exactly the same way we did it on the connected environment, we're going to do it on the disconnected environment, right? It's the same data that we're pushing in. All right, I talked a little bit about how we're trying to make this easy. Obviously, the witness CLI, a lot of places to fat finger it. Probably going to want to write some templating or scripts around it if you're going to do that. But we do provide, if you're using GitLab or GitHub, we do have integrations with them. So we have this witness run GitHub action, and it makes it a lot easier. We can enable Archivista and SigStore. That will push attestations up to the cloud, and that will allow you to sign using SigStore without any developer configuration at all, right? And then all you do is you specify your command. Now everything's attested. We're collecting the metadata about that. All it left is to do is to create the policies for those and put that gate in where you need to. Right. So when we talk to open source projects or commercial projects about how they want to adopt this, the first thing is let's just start collecting the information, right? Use our open source tooling that we've developed, Witness, Archivista, as well as a GitHub action, and start collecting that metadata, right? This allows you to look at actually what happened. If you do have a supply chain attack on your project, now we have the metadata and can go back and do an investigation on. This is fairly low effort, especially if you're going to be doing it around your build steps, right? That's just one step. Increase your security significantly. Depending on who you ask, Witness and how you implement it, Witness is like Salsa 2.5 or Salsa 3, right? It really depends on the KMS and the build system in order to make that determination, but they'll get you from Salsa 0 to right there in just a few hours. The next thing you want to do is start creating that policy around the KPIs that you care about, right? And put that into more of an audit mode. That is where, yeah, it's going to fail that step in GitHub or GitLab, but it's going to notify the developers of the deficiency, and we're not going to slow them down at all. And then finally, once that seems to be going pretty well, that's when you can bring in the enforcement. And you may not even want to do this on the open source side. You may want to keep that monitor, but then in the environments where it really does matter, right, they can use that policy that's developed and distributed to enforce it to make sure that those artifacts meet the compliance requirements or meet the standard that that project set. So we actually do have a enterprise platform that does a lot of this, Testifysec Enterprise for Witness. It also takes all this data and maps it to compliance controls. So if you have any NIST 853, SOC 2, stuff like that, we can help a lot with that as well. So we can deploy this pretty much anywhere. Deploys with if you've got Kubernetes running, we can run this. All it's required is a KMS, S3, and then some sort of SQL database, Postgres, MySQL, something like that. And purpose built for air gap environments. But that's all I got. What are your questions? I know y'all been talking about signing RPMs for a while. I know there's some options out there.
So as I guess you haven't been here all week, the whole week. But as is tradition, I will ask the first question and probably the second question and maybe the third question.
I love it.
Maybe all the questions. So what we're doing today is we are an open source project that is trying to provide stuff for air gapped solutions. And our answer today is we use GitHub attestations to attest everything we do. And so as I'm walking through, as you were walking through, like how would we incorporate Witness and the format Archivista with the future, I think that sort of made sense to me. So now we use those, we use what we're already doing. We use Witness to kind of bring that through, and then we are able to verify on the other side of an air gap all of the things that were built through GitHub, and we can now use the GitHub action that you're proposing as well. My other understanding looking through this is we often get the question, how did the cluster change between when this job was run previously and when the job is run now? And as you were like going through all of the attestations, it made me wonder, could we be using Witness as we do job start and creating a document that says, here's the full state of the cluster when we run the job, and then going back through that later to compare that with results?
Yes, we actually have a K8s manifest attester. So if you run like a Helm template, as part of your CI or CD process, we will capture all the output from there. Everything's really designed to work pre-production as like a more of a developer tool. But there's no reason why you can't run a kubectl, get all output JSON, right? And you'll get that as well. So you can use it to track that between deployments for sure.
I think you said you're using Sift, right?
Yes,
To get the S-bombs over.
in this demo, we're using Sift.
Yeah. So I know Sift works on container images. So it'll give you like everything that's in the container image. So that's depending on how you build your images for your cluster or something, right? You can get a diff between versions of what's in there. So I've actually tried to do this, and it all works. But the problem I have is I use another tool. I think it's called Gripe. It's the same company or whatever, or same group. And I get a big list of vulnerabilities, right? Like a basic rel 9 image, right? So I didn't do anything fancy. I just did like a group install, the basic core thing or whatever. And there's just like hundreds, right, of vulnerabilities. And you go look up the ID or whatever on Red Hat, and they just say, well, we're not going to fix it. Right? So I mean, it's tangentially related to this, but I don't know how to handle these situations, right? So there is a vulnerability and there's a fix for it. Like, what do we do?
Depends on
Yeah.
depends on your requirements, right? What are your compliance overloads currently to do? I know in like for example, FedRAMP moderate environment, you're going to have 30 days to remediate that vulnerability, or you're going to have to write a poem, and nobody wants to write poems. So the best thing to do is not have them at all. There's a company called ChainGuard that has a product that's really good for this. We actually use them for all of our base images. But really it's about tracking, understanding where it's at, and figuring out where you want to put your engineering effort. We use Go, which is really nice for all of our back end. So we can use from scratch for almost anything. So we don't have to pay ChainGuard that much money. I know if you're using like Java and some of these like Python, it's just, I mean, no, the problem starts to become a little bit more intractable.
So as we're the witness stuff, how flexible is that to do things that you haven't thought of? To look at the kinds of payloads that you haven't thought of yet?
Well, you can do anything with code, right? Especially these days. No, it's an observation tool. So you define the observations that you want to make, right? It's a measurement, but you have to define those measurements. So we have a bunch of measurement tools out of the box that we call the clusters that will go and inspect the job that GitLab or GitHub issued, right? And collect metadata off that, or it might run strace on the command and take measurements off of that. So you can build your own measurements tools to measure the things that you want to about your process, and then build a policy. That's really what we built the tool to do, is to be flexible like that. For one of our early customers was a really big bank, and their identity system isn't used anywhere else. They built it themselves. Right? It's kind of like a JOT, but it's not. So we had to build a custom tester for them in order to collect the metadata off of that. Right? Nobody else will ever use that. But it only took us like a day because of the plugin system that we had for witness to incorporate that in.
So one of the other, I'm just going to keep, anyone else want this microphone, or is this just my microphone now? All right. So as an open source project that it's a microservices based architecture. We've got multiple repos that are coming together into one release. And that release is now an RPM that references a bunch of containers. And so when you install the RPM, you then pull the containers as part of the installing of the RPM, because that's how we work. That's how this has worked for us. At which points of this do you think we should be, like, I guess if we're trying to tell someone, here's how you adopt an attested version of OpenCHAMI, can you help us think through how would each of those pieces fit together beyond a single Go binary?
All right. So I think you have an RPM file that references a bunch of containers. I think as part of the spec file, you'd want to maybe run witness verify. And then also include all the metadata, except maybe you might not want to include the policy. You might want to do that as a side channel, but then push all the other attestation, everything that's required to do the verification into the actual RPM itself too. So then maybe the RPM is running witness verify and we don't ever have to actually run that. I mean, we don't have to run witness verify in RPM. It could also kind of, when you install the RPM, it could just kind of unpack and validate itself if you give it a policy.
And so then the RPM then gets signed with GPG so that it works with RPM-I. And then once that's in, that as part of its installation, it is then running the witness on the attestations that have been done and are packaged with the RPM. Is that right?
Yeah, I think so. I think that could work. We had to think about it some more.
Okay. And then so somebody consuming this, we can say, okay, if you want to put in your, like our default policy, which is going to come with it, is going to say this came from OpenCHAMI and it was built on GitHub through our runners in a way that we can trace. But then if they want to add their own stuff to say, well, we're only going to accept containers with a base image, with these 10 base images. And so if we make a switch, we can still ship it all out. And then they can say, wait a second, our policies does not allow a Red Hat based image. It has to be a chain guard based image. Is that how a consumer might be able to take a look at this?
The consumer can apply whatever policy they want to it.
Yeah, okay.
And then policies are signed too. So you can actually distribute keys within them. Or public keys within them for verification because you need to validate that policy too. So I think it works well with that. Because now we know the policy is distributed by the OpenCHAMI project, right?
Mhm.
And that policy has like almost sub policies in it that validated that these are the policies we care about.
Cool.
Too many turtles.
Well, I mean, it's validating microservices in an RPM format that, we don't have a good answer today. We do basic attestation of the microservices, and that's as far as we can get. This is really helpful.
Yeah, I'll take a look at your spec file.
Okay.
Tear it apart a little bit.
Well, this has been great. I want to thank you. Is there any other questions before we give you a round of applause? Thank you very much.